Hi, this video is called angle, angle, side, and HL. So I really have two more ways in addition to side, 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 and side, angle to prove congruent triangles. Triangles, right? So far we have, remember, side, 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 and side, angle. The next two ways are called angle, angle, side. That's this case right here. And what we call HL. So I'll talk you through each one. Angle, angle, side is similar to angle, side, angle, but it's a little different. If you remember with angle, side, angle, the two triangles, if they had this particular angle, side, angle relationship, would share two pairs of congruent angles, right? Angle and another congruent pair of angles. Right? And the side that they share in common is the included side, right? Right here, that's the included side. That's why it's called angle, side, angle. Now this technique, angle, angle, side, is a little different. Okay? And what angle, angle, side says is we still have two pairs of congruent angles and a pair of congruent sides, but the side that we know to be congruent is not the included side, right? So the included side, using this particular diagram, would be these guys, right? Between the two pairs of congruent 1, 2, 1, 2, right? So angles, angles, and if it were angle, side, angle, we know that these sides, the included sides, will be congruent. However, it's not angle, side, angle, it's angle, angle, side, and this always also works too. So note that the congruent sides are the non-included sides, not the sides between the two congruent angles. So what angle, angle, side says is if two triangles, and I'll write triangles like that, share basically the same, or two pairs I should say, two pairs of congruent angles, and not the included side, because that would be angle, side, angle, but and a non-included pair side, right? If it were the included side, it would be angle, side, angle. Then the triangles are congruent, right? Or of course the same, right? And that's called angle, angle, side, right? Angle, angle, side, right? Non-included side. Okay, the included side would be these guys right here. That would be angle, side, angle. Okay. The other technique is called HL, right? And HL stands for hypotenuse, leg. And if you remember, hypotenuse is the longest side of a triangle. And you might also agree that if it's a right triangle, then the hypotenuse will be the side across from the 90-degree angle, and that's correct. So what HL says is if we have two right triangles with congruent hypotenuses and a pair of congruent legs, okay, and we also need the right angle piece, that's essential, right? Then those two triangles will be congruent, okay? So this is called HL, H for hypotenuse, the two yellow pieces, and the legs can be either these two green sides, or we could certainly also have these two sides being congruent. That would also be hypotenuse leg. Okay, so let's kind of generalize this. What HL says is if two triangles share, actually let me be more specific. If two right triangles, okay, that has to happen. Two right triangles share common hypotenuse, or I should say congruent, sorry, I'm a little tired. Congruent hypotenuses, hypotenuses, and legs, then the triangles are congruent. Okay, and it's called HL because H is for hypotenuse, right? Hypotenuses, and we need congruent legs. That's why it's called HL. Okay. Now, there are always three things we need to show congruent triangles, right? If it's side, 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 we need 3 pairs of congruent sides. Side, angle, side, we need 2 pairs of congruent angles, and the congruent included, 2 pairs of congruent sides, and the included congruent angles. Angle, side, angle, again, 3 things. We also have 3 things, of course, for angle, angle, side. And believe it or not, we have 3 things for HL. One of those 3 things is this piece here. We have to have right triangles, right? So we need that right angle there. Okay, and then of course we have congruent hypotenuses here, and we have congruent legs here. Okay, so all of the techniques in which now we have 5 to show 2 triangles to be congruent, we have to establish 3 things exist. Okay, we'll talk about why some of the other ones don't work eventually, but not now. So let's look at how we might use this. So here's a particular problem. If I scroll down here, and so here's an example, and let's say, so suppose, well, everything given essentially, right? So suppose that NP is congruent to ON, and this line right here is called an altitude, right? If it's 90, if it hits from a triangle, right, from one of the vertices, it's perpendicular to the opposite side. So I guess we can say that in a number of different ways, but we'll say NQ is perpendicular to PO. What if I want to prove in this case that, I don't know, let's say PQ is congruent to OQ. Okay. So I'm going to go about this by first showing the triangles to be congruent. And in this case, I have right triangles, right? I have congruent hypotenuses, and I have, by the reflexive property, congruent legs, right? So I'm going to use HL. Okay, so to establish that, I have to say, I guess, note right triangles. And we're going to be a little lazy there, right? There are a lot of different ways to say that, and that's enough, right? We have right triangles based on what's given, right? These are 90 or perpendicular, whatever. Okay, so those are 90. So we have 2 right triangles, okay? And that's one of the 3 things that has to be satisfied if we're using HL, okay? And the hypotenuse P N is congruent to ON, right? Those are my congruent hypotenuses, right? That's also given. Okay. I'm going to get a pair of congruent legs by the reflexive property. Okay, here it is right here. ON is congruent to itself. Excuse me, QN, congruent to itself. And that's my pair of congruent legs, right? So now I've established 3 things: right triangles, congruent hypotenuses, congruent legs. So therefore, the triangles are congruent. Triangle PQN is congruent to triangle OQN. That's an O, and that's going to be by HL, right? Congruent hypotenuses, congruent legs, and right triangles. Okay. So now, since the whole triangles are congruent, I certainly know that these 2 corresponding pieces will be congruent. And that's by CP, CTC. I get PQ, oh, PQ, PQ, it's not working here, congruent to QO. Okay. That got a little messy there. Apologize for that. Pen's not cooperating with me. Okay, so that's HL. So we have 2 new ways to show congruent triangles. HL, again, really that requires 3 things: right triangles, congruent hypotenuses, congruent legs, or angle, angle, side, which is similar to angle, side, angle, but we don't have the included congruent side, so non-included congruent side. Okay, thanks for listening. See you tomorrow in class. Bye-bye.